this tutorial, we're going to cover lexical environment. It would be really difficult to become any good at JavaScript without first understanding lexical environment. A lot of coders jump directly into variables, functions, objects, and so on. And they sort of just skip talking about lexical environment. But later on it catches up with them in the way of unusual mistakes and all kinds of stuff coming up. For example, why a particular variable value returns undefined instead of an actual value, and just stuff like that. These types of mistakes can be made if you don't understand how lexical environment works in JavaScript. Lexical environment is really just another way of talking about scope. And as you may know, scope is defined by curly brackets. So this is a valid statement where you have just empty bracket. But what you did here is you created a new lexical environment. Without the brackets, the lexical environment of this script tag is also valid and usually referred to as the global scope. But by creating a new scope within the global scope, you basically created a new lexical environment. Okay? One major trait of lexical environments is that they can be nested. So you can have as many lexical environments within other ones as you want. So in this case, this will be an inner lexical environment. This will be an outer lexical environment from the vantage point of this one, and so on and so forth. And they keep going all the way back to the global scope. Of course, in a real case scenario, you'll never have anything like this. A lot of the time, lexical environments are nested and spaced out like this. I mean, you've seen this before. We use that in functions and in some other cases. But basically, separating them with 4 spaces or 2, as some people find popular these days. I use 4. Anyways, now let's define a simple variable here in global scope and assign it a value of 1. Now, from this point on, because we use the var keyword, this variable will be available in all of these scopes, including this one, and here. So if you console it out, it will actually show you that it's equal 1 because it's sort of propagated through this here and ended up here. Now, the funny thing about variables defined using the var keyword is that they are moved up the scopes. Let me demonstrate that. If I move that declaration and assignment into the scope, the variable a will actually be hoisted. And hoisting is a term in JavaScript in reference to how variables that are declared in an inner scope will actually travel up. So it's the same as if we had something like this here. And this is done behind the scenes in JavaScript. So whenever you declare something in a scope using the var keyword, it's going to travel up here and be available here. However, one very important point here to notice is that only the declaration, not the value definition, the declaration will be traveling up in here. So at this point, even though the variable is open for access in the global scope, even after you define it here, it is still undefined because, again, only the declaration travels up when we use the var keyword. And you can access it here, but it's undefined, so that's no use. This is why it's always a good habit to define your variables on top of the scope instead of in some inner scope, unless you really want to conceal that variable in some inner scope. And to conceal something, you will use a let keyword. So let is not hoisted up here. So if you define something using let, it will only be available within this lexical environment and any environment within it. So let here is going to be 1 because it's inside this lexical environment, but you will not be able to access it here. It's no longer be undefined. It's simply gonna create some kind of an error and break your entire JavaScript application because you're trying to access a variable that's defined using the let keyword inside some inner scope. And Again, if we change that to var, that would be another matter. We would have undefined again right here, but that's usually not a great practice on coding. Try to always define variables up top here. And if you really need to conceal variable inside some scope, use the let keyword. So it's not going to jump out of here into some global scope. Now, there are different types of lexical environments in JavaScript. The one that we just covered is called block scope because it's just a block of code. You can type any code in here, and this is just another outer block scope. And remember, this is the global scope defined by the script tags. But another important lexical environment is used when we create functions. So basically, whenever you use curly brackets, that defines a lexical environment. In the same way, we can create a function with its own lexical environment. So that's a little different, because the difference here from the block scope lexical environment is that when it comes to functions, the lexical environment for a function is created not when the function is defined, but when a function is actually executed. So when you call this function, that's when this lexical environment is created. And you might have all kinds of parameters, and they will be just available here, concealed to this lexical environment. Whatever the user passed into this function as an argument is going to be here. So let's say 1 for k. Again, remember, this is important. Lexical environment for a function is created not when it's defined, but when it's executed. In JavaScript, you can have functions defined within functions. So, for example, function B can have its own lexical environment. Function C can have its own lexical environment. And that's all within the function in itself. So all of these environments are concealed to these areas that they define. Apparently, whatever you define inside the function will not be hoisted into the global scope. So functions are pretty much concealed to their own scope. Whenever we create a for loop, we also create a lexical environment. And so within this lexical environment, we have all these variable definitions. So it's going to go through from 0 to 9. I'm going to open console here, and I'll change this to 3 so we don't get too many values. I'll output I in the console, so let me refresh that here. We will see that we got 0, 1, and 2, which is the variables that we iterated here 3 times. There's a built-in function called setTimeout in JavaScript. And it takes a callback function, which is anonymous function. It doesn't need a name. And so if I put this console into this callback function and say set timeout every 1 second, notice that I moved the console function into the lexical environment of set timeout, and now it's a anonymous callback function. So it operates in a different lexical environment, separated from the for loop. Now we're almost overlapping here with another concept called execution context and execution call stack, but I'll have to make another tutorial just to cover that. Apparently the lexical context here is not the only thing contributing to the results we're about to see in the console. So what's going to happen here is the for loop is going to finish at digit 3. And let's see what the console will say in this case. Remember, we now have this concealed in a new lexical environment inside its setTimeout function. Refresh the console. And you will see after 1 second, we actually had 3 outputted 3 times. So the value of I in this case did not iterate 3 times. It's almost like it got stuck on 3 and it console outputted it 3 times on the last value. Now the reason this happened is because for loop finished and we got 3, and that's what the console came up with because it ran actually 1 second after the for loop has been executed. But it's kind of tricky because we outputted it inside the for loop. And again, this is a different lexical environment. In JavaScript, we have something called an immediately invoked function. Basically, it's just like a function like any other, but what you do is you wrap it in parentheses and you call it like you would any other function. And notice that it doesn't even have to have a name. So basically you create the function, wrap it in parentheses, and then you execute it by calling the function. It's just like if you had a function called A, you would do this. But because this function doesn't have a name, we just simply call it right away. You would not be able to do this. This would simply not work. So that's why we need to wrap the definition of that function in parentheses first, only then call it. This is a very common pattern. It's used for creating plugins of all sorts in JavaScript. But the point of this part in this tutorial is I want to demonstrate something. Let's take this function and wrap this statement in one. And so we're going to close it up here, and let's say we'll execute it. If I execute this code in the console, we'll get exactly the same result as we did last time. So nothing changed. We just wrapped this statement inside a lexical context of an anonymous function, created and executed at the same time. But let's add a variable called j and assign the I value within this lexical environment. And so instead of outputting I, we'll output j. So we redefine I, which was captured from here in this lexical environment, and instead of I, we now output j. So let's see what happens. Refresh the console, and as you can see, we're back to 0, 1, 2 individually, even though we're using the set timeout function. And now again, without understanding the execution context, which is one of the next subjects of my tutorials, it will be difficult to understand how this really happened. I'll have to leave it at that at this point, but the idea behind this example was to demonstrate that given enough lexical environment contexts and execution contexts, it's possible to achieve this functionality even though we're using a set timeout function. And back when ECMAScript 5 is all we had to write code like this just to make sure that it works the way we expect it to work. But the funny thing is, after ECMAScript 6 and the let keyword, so if I rename this to let, we don't need any of this. So let's delete this and delete this function here and move this back. And so all I did was change from var to let, and now we also need to output I. Because we defined this value with let keyword and it exists in this lexical environment, the set timeout function will actually grab the correct values. So let's take a look at that. I'm going to save that and open that in the console. And as you will see, it actually gives us the right values even though we're in a set timeout function. Again, that's because we used the let keyword instead of var. If I do the var and refresh this, we're going to go back to the 3. And there's one more thing I wanted to mention. Let's say we have something like this. We're using var keyword here, so the values will naturally trickle down. But in fact, you can actually use let if you really want to, because let still trickles down into the scope. It just doesn't get out of the outer scope. Okay, so if I'm going to save this and refresh the console, you'll see that we get the value 2 here. As I progressively start deleting the definitions here and refreshing the console, you'll see that now it's equals 1, because what happened here, first, JavaScript is looking for X defined in this lexical context. When it doesn't find it, it just goes up one level and starts looking for it in this lexical environment. Here it found it, and so we have output in the console. But if we continue progressively deleting these variables and I'm going to refresh, again, it looked in this one, didn't find it. Then it looked in this one, didn't find it. And so it went all the way to the global scope and it found it here. And so that's why we have 0 now. So that's pretty much how lexical environments work. They keep progressing up the scope levels in order to find variables. Thanks for watching, guys.